Welcome to this video tutorial from spssvideotutor.com. I'm Jacob Mays, and today we will cover correlation analysis. In this video, you will learn how to perform and interpret a bivariate correlation in SPSS. Now let's look at how we actually run a correlation in SPSS. In this demonstration, I will use a data file called world95.sav. You can find it in the SPSS sample data folder. This data set has information on 109 countries, from Afghanistan all the way to Zambia. It includes statistics on population, population density, religion, life expectancy, and so on and so forth. Let's begin by examining the relationship between female life expectancy and 4 other variables, namely literacy, gross domestic product, daily calorie intake, and birth rate per 1,000. The first step is to click on Analyze, then go down to Correlate, and then click on Bivariate. In step 2, select the variables you want to analyze and move them into the variables box. So let's select female life expectancy. Let's see, literacy, gross domestic product, daily calorie intake, and birth rate per 1,000. Under correlation coefficients, the Pearson correlation coefficient is selected by default. This is used for quantitative variables that are normally distributed. If you know that your data is not normally distributed, then you should choose Spearman. Under test of significance, make sure that two-tailed is selected, and also make sure that flag for significant correlations is also selected. Now we go over to options over here on the right. Click on that. Under missing values, make sure that exclude cases pairwise is selected. Hit continue, then click OK. You will notice that the results display in what we call an output window. The results of all of your analysis show up in this window. The first thing we see is the syntax statement up here. This is a written record of the command just executed. Next, you will see the name of the analysis run, which is correlation, followed by the name and path of the data file used, right here. And then below that, we have the correlation matrix. Notice that the 5 variables we have chosen are displayed across the top and along the sides of the correlation matrix. In each box, we have the correlation of the variable in the row and the variable in the column. So, for example, the variable in the row is gross domestic product, and then the variable in the column is average female life expectancy. So this is the box that corresponds with that. So then the next one, daily caloric intake, and average family life expectancy, is the box that corresponds with that. Where you see the ones going along the diagonal, that's each variable correlated with itself. So that's birth rate correlated with birth rate per 1,000, daily calorie intake correlated with daily calorie intake, and of course these are all perfect correlations. Also, the matrix is symmetrical along the diagonal. So the 0.865 correlation here is the same 0.865 correlation here. It's people who read, average female life expectancy, and then people who read over here, an average female life expectancy. Remember, Correlations go from -1 to +1, where the absolute value determines the strength of the relationship and the sign in front of the number determines the direction of the relationship. In each cell, you will see three numbers. The first number is the Pearson R correlation, or the Pearson product moment correlation coefficient, better known as simply R. In this example, it is 0.865, which is pretty high and a very strong positive correlation. This indicates that as literacy increases, so too does female life expectancy. The second number is the significance level, or the p-value. If this number is less than 0.05, then we say that the correlation is considered statistically significant. All this really means is that we are extremely confident that an R of 0.865 did not occur by chance. The final number is the number of cases in this analysis. In this instance, the value represents the number of countries that had data for both average female life expectancy and literacy rate. Okay? The key takeaway here is that all of these correlations are statistically significant. Okay? So if you look, you notice that all of the R's have stars after them, which means that they are statistically significant. Of course, excluding the perfect correlations going down the diagonal. So for example, birth rate per 1,000, as the birth rate decreases, average female life expectancy increases. This is an inverse relationship. As birth rate decreases, the percentage of people in a country who read increases. As birth rate decreases, the gross domestic product of a country increases. As birth rate decreases, daily caloric intake increases, and so on and so forth. We will use these same variables in the multiple regression tutorial, where we look at the association of all of these variables collectively. So once you have interpreted the results from the SPSS output, the next and final stage is to report your results in APA format. So the first thing that you're going to do is you're going to indicate the particular analysis that you've conducted. 3, 2, 1. So the first thing that you're going to do is you're going to state the purpose of the analysis that you've conducted, as well as the particular test that you use to execute the analysis. All right. So a Pearson product moment correlation analysis was used to investigate the relationship between 5 socioeconomic variables across 109 countries. All right. The next thing you do is describe the variables in details. The socioeconomic variables were female life expectancy, birth rate, gross domestic product, literacy, and caloric intake. Higher values for each of the 5 values. 3, 2, 1. Higher values for each of the 5 variables corresponded to higher levels of gross domestic product, birth rate per 1,000, and caloric intake. 3, 2, 1. Higher values for each of the 5 variables corresponded to higher levels of domestic product. 3, 2, 1. Higher levels for each of the 5 variables corresponded to higher levels of gross domestic product, birth weight per 1,000, caloric intake, and longer life expectancy. That's not 5. 3, 2, 1. Higher values for each of the 5 variables corresponded to higher levels of gross domestic product, birth rate per 1,000, caloric intake, literacy levels, and longer life expectancy for women in their respective countries. Now, the next paragraph you state the null and alternative hypotheses. Okay? The null hypothesis states that there is no linear relationship between the socioeconomic variables. Now notice I put in here in parentheses any of, because when you say it this way, the implication is that there is no linear relationship between any combination of the socioeconomic variables. Because remember, this is a bivariate correlation, so each variable is being compared to one other variable. So the hypothesis, the null hypothesis, means that there is no linear combination between any two variables. All right, just want to make that clear. The alternative hypothesis states that there is a linear relationship between the socioeconomic variables. So it's just the opposite of the null hypothesis. Now, the third paragraph is where you actually state the results. Based on the conventional definition of effect size for correlations, ignoring the sign, that's just a message to you. You don't write that in your results. Where 0.10 to 0.29 is small, 0.30 to 0.49 is medium, and 0.50 to 1.0 is large, or strong correlation, weak correlation, or moderate correlation. There was a strong correlation between all of the socioeconomic variables. Average female life expectancy was significantly correlated with literacy. So you write R, italicize, the case number or the number of cases in parentheses for that analysis, the correlation coefficient, and the significance value. Now, when your significance value in the SPSS output is 0.000, then APA stipulates that you need to write this as P is less than 0.001. Now, if the significance value in your SPSS output is 0.001 or greater, then APA stipulates that you need to note the actual significance value. So it would be P equals 0.001, or P equals 0.86, or whatever the actual value is. Gross domestic product, R, again, the case number, correlation coefficient, and the p-value or significance value. Daily caloric intake, same statistical notation. Birth rate, statistical notation. There was also a significant correlation between literacy and gross domestic product. Again, statistical notation, daily caloric intake, and birth rate. Again, statistical notation. There should be a comma there. Essentially what you're doing here is you're stating all of the results of the correlation analysis within your write-up. Okay? Now, there is a second way to do this when you're using a table. When you're using a table, you do not duplicate what is in the table and what is in the actual write-up. So essentially what you would do is you would summarize the results and then put the actual results in a table. The results of the correlation analysis indicated that the correlation coefficients range from minus 0.642, the lowest correlation coefficient, regardless of the sign, to minus 0.869, the highest correlation coefficient, regardless of the sign. Based on the conventional definition of effect size for correlations, which I've already stipulated or described earlier, there was a strong correlation between all of the socioeconomic variables. Results of the bivariate correlations are below. Now, if for some reason your correlation coefficients, some of them were large, some of them were medium, and some of them were small, then you would group the large explanations together. You would group the reporting of the medium or moderate size correlation coefficients together, and you would group the small correlation coefficients together, the descriptions of the small correlation coefficients, and then you would say the results of the bivariate correlations are below. Now, so to create your table is pretty straightforward. So it depends on the number of correlations that you have. So you have the correlations going down the far left column. You number the correlations, and then you have the corresponding numbers going across the top of the table. So average female life expectancy is 1. So that correlated with itself is a 1, but you just write a dash. And then, so it's average female life expectancy and literacy, average female life expectancy and gross domestic product, and so on and so forth. Now in your tables, APA allows you to indicate P is less than 0.05, P is less than 0.01, P is less than 0.001 by either using a single a double or triple asterisk. Okay?
If you have any questions, please submit them to help@spssvideotutor@gmail.com. This has been a video tutorial from spssvideotutor.com. Thank you for watching and much success with SPSS.